up, guys? Welcome back to the channel. Thank you guys for tuning in on today's video. We are installing beehive valve springs on the 7.3 engine here, and nobody has gone over in a really good detailed video the best way to do this. So we're gonna go over part numbers, we're gonna go over the tools that you need, we're gonna go over how to make the measurements and shim properly for the correct installed height of your spring for a certain amount of seat pressure. We're gonna go over it all. The installation, you name it, all of it. So let's jump right into the video. I hope you guys enjoy the video. So first things first, let's go over the two tools that are pretty much required in order to do this process and do this process correctly. The first thing being our BTR Brian Tooley Racing height micrometer. So this micrometer is going to help you measure the installed height so that you know how many shims that you need. Which brings us to here. We've got 60,000 shims, we've got 30,000 shims, and we've got 15,000 shims. So this tool right here is a must because we are trying to get to a proper installed height of our valve spring, and we need this tool to know how much we need to shim it in order to get that proper installed height. Second tool, this guy right here. This one is made by OTC. There is the part number for you. This is specifically for a 7.3 and compressing the valve springs in order to remove the valve springs. Now, there are some other companies that make a nice kit here. Some guys I know make them, custom make them at home. It's pretty simple. This is gonna thread down into a hole in the block, and then this is going to compress the valve spring, get your retainers out, your locks, and then boom, the valve spring is removed. So these two tools are a must. You have to have them in order to do this job. There are a lot of companies that make valve spring kits, you know, a stage 1 kit, a stage 2 kit. You can get those kits and they should provide you with the installed height that they want those valve springs to be installed at for a specific seat pressure. Seat pressure meaning how much pressure is holding that valve up against the head and keeping it in place. What we are trying to effectively do here is prevent valve float when when the boost pressure is elevated to a certain point that there's a lot of pressure trying to force that valve open, specifically on the intake side, but also on the exhaust side. So that is why we upgrade our valve springs. The Beehive valve springs is a really high quality design. Valve springs have come a long way since 1996. And so, previous to companies coming out with kits to do valve springs on the 7.3, everybody was selling comp cams, and they were kind of manipulating the valve or the valve springs. They found a couple part numbers that would work on the 7.3 engine. So we're going to go over both of those part numbers, some of the differences, and then you can ultimately decide which one you want to go with. So this is the part number that I decided to use right here, 26056, and a quantity of 16. Now what you'll notice on here is that at 160 pounds, in order to achieve 160 pounds, these need to have an installed height of 1.8 inches. So that is our target height with these set of springs. You can see coil bind there at 1.1. The spring rate, 400 pounds per inch. These valve springs have been used by a handful of people without issue. You can see right here, here is our steel retainers. And then right here is our valve lock. So 610 by 16 and then 703 by 16. So those are the appropriate locks and retainers for this particular valve spring. You can see we have a bunch of them here. These ones we've already done on our driver's side. I'm going to be showing you guys on the passenger side. There are our locks. The retainers are sitting on top here. These are the retainers. You can sit on top just like that. I should also mention this is a great opportunity to replace your valve seals. You should be replacing your valve seals if you're going to have the valve springs off. So this is the Ford part number. They come in a package of 4. So you're going to need 4 of these for a total of 16 in order to properly reseal the valve seals, and install your new valve springs. Now, the other part number that you can get that a lot of people use is the 26-120 by 16 quantity. That part number there is another really good one to use, and a lot of people do use that part number. I believe the installed height on that is 1.88 inches, which gives you, I think, about 155 spring pressure. So there's minor differences between the two. You're basically gaining about 5 pounds of seat pressure by going up to the 26-056. There's slight differences in the actual springs themselves. The installed height is definitely by far the biggest difference from comp cams that they want you to install those springs at. Being that you can run at 1.88 and still achieve 155 pounds, should in theory require less shims than your 1.8 for the 26-056 springs. So that might be an advantage. Looking back, I probably would go with the 26-120s. Irregardless, every truck is pretty much going to need to be shimmed unless you pull the heads off. So go get a set of shims that are going to match the springs. All of that information is on CompCam's website. Down in the description, after you select the spring, you're going to see recommended parts to go with it. That's going to include the retainers, the locks, and all that stuff that are meant for those springs. Now, you can manipulate a little bit with spring pressure. You can shim them less. You can increase the installed height to 1.9 if you wanted to. It really depends on the setup. This particular truck, we are probably going to be pushing somewhere around 50, 60, maybe a little over 60 pounds of boost. So it's really simple math. You can take the surface area of the valve and you can multiply that by your boost pressure, whatever you think you might be creating, and then in theory that should give you the amount of pressure that's going to be pushing down on that spring, or the amount of pressure that's going to be pushing on the valve, which is in turn going to be pushing on the spring. So the math on that basically comes out to, if you're going to be over 60 pounds of boost, then you should probably go with a higher installed height, at least 160, if not more. I know there's some guys out there that are pushing 180 seat pressure, 190, 200 seat pressure. At some point, you do have to be concerned with the amount of pressure that you're putting on the rest of the valve train. Push rods, and more importantly, our little tiny, actually they're pretty decent size, our lifters, but our hydraulic lifters, we're adding a lot of strain and a lot of pressure on those lifters. So just be conscientious of that. You're better off setting up the valve spring installed height at the perfect seat pressure than overdoing it because of that extra strain and pressure on the rest of the valve train. So like I said, we installed all of the ones on the driver's side. You can see pretty much every single one needed shims. I will show you guys. This is my little notepad, intake and exhaust. You can see our exhaust was, almost all of our exhausts were over 2. And then our intakes were around that 1.9 area, 1.9 to 1.95 area. A couple of things to keep in mind. Your valve seal, this guy right here, accounts for a shim. You can see there is a flat area right there. The spring is going to go over top of that. So something to keep in mind is that your valve seal is going to account for 0.043 to 45 thousandths, right in that range. A lot of guys just go by 45 thousandths, but I have measured these and some of them are coming back at 43 thousandths. So that kind of helps you give a little bit more leeway if you need another 2 thousandths. Either way, we're going to shoot for 1.8 to 1.805 at the most. So somewhere in that range is what we're kind of aiming for to get that 160 pounds of seat pressure. So you guys can see that we do have our injectors removed. That is not necessary in order to do this job. You can simply just remove the glow plug, but either way, you have to be able to get to the top of the piston because what we're going to be doing is we need the piston to be at top dead center in order to relieve the pressure off of these springs and get the springs removed. That way, when the piston is at top dead center, our valve will only drop a little bit. It's not going to drop all the way down into the cylinder. And so basically I'm going to be using the ejector bore. You can see my pick is going pretty far down in there. And so we're going to have to turn this engine over and wait until we get to top dead center. So using a 15/16 socket right here on the harmonic balancer, we are just going to simply turn the engine over. You can see the piston is coming up, and it looked like it pretty much just stopped. So now with the piston at top dead center, we can go ahead and remove our rocker arm assemblies and push rods. We do have our rocker arms marked here. You can see cylinder number 1, cylinder number 3, 5, and 7. So when we remove these, we're going to try to keep these together, intake and exhaust. And the other thing I want to mention too is we do have new push rods as well. So we're going to be scrapping the push rods, basically everything with the valve spring. The only thing we're keeping at this point is going to be our rocker arm assemblies. So using a 12.8 millimeter, these aren't torqued very much. We can go ahead and crack these loose. So now with those removed, we can take our valve spring compressor and go ahead and install that. You can see it's going to use one of the rocker arm bolt holes. Get this guy snug down. Now with the pedestal portion of it snug down, we can go ahead and compress our valve spring. You want to make sure you're fairly centered on it when you do this. It is common for the valve to drop a little bit until it hits the top of the piston, but then it should stop. So now we can see both of our retainers, our locks, not our retainers, our locks. We'll grab a magnet. We'll just pick these guys out. You don't want to drop these. You'll be going fishing for a while. We don't need those again, so we can go ahead and toss those off to the side. And now we can go ahead and loosen this guy back up. I'm gonna get you guys a close-up shot of this when we do the other one. And there it is. You can go ahead and remove that entire assembly. Like I said, we're going to take our tool here, get it threaded into the rocker arm pedestal bolt hole. Get that snugged up. Now we can go ahead and thread this down, making sure we're over top of the valve spring. Like I said, the valve will drop just a little bit and then it'll stop. Once we can see both of our locks, we can go ahead and grab our magnet. pick both of these out of here. Maybe. Come on. Just need a little more room. Now we release tension. Pull our tool off. And remove the entire assembly. For our old valve seals, just grab a pair of pliers, grab a hold of them, give them a little bit of a twist and a pull, and they pop right off. Again, we can throw these ones in the garbage. They're no good to us. At this point, you can see our valves move up and down. A lot of times what I like to do is I just like to spin them a little bit, pull them up and spin them in case there's any little bit of buildup. It kind of can help keep them moving, keep them free, and it could mess with our measurements, so we just like to make sure that everything feels like it's seating properly and moves properly. These feel pretty good. Okay, so now we get to do the fun part. We're gonna grab our micrometer, we're gonna spin it out just a little bit. We're gonna grab our new valve spring retainer and we're gonna set this on the top hat. So you can see it sits flush on this top hat. We have two of our locks. We're gonna go ahead and drop this down over the valve. Grab our new locks and slide that over top of the valve. You can see what you might have to do is kind of move our tool up and down, but basically this is what we're looking for. Our valve locks are in place, they're seated inside of the retainer. We have lifted up on the tool and there is a big gap underneath the tool. So now, holding the top, we're going to take our other finger and we're just going to try to spin the bottom down until it gets tight. Okay, so now our tool is relatively tight in here. It's not going to move around. And we want to look for the numbers that are on the inside sleeve. So I'm just going to turn the top until I see the numbers. It's starting to get too tight, so I don't want to go too far, but I can see the numbers right here. Let me adjust the camera. All right, so you can see the numbers on the side here. Those are the important ones, and then there's on the lower collar, there's dashes that go up and down. The first numbers that we're worried about are the numbers on the inside sleeve here that go horizontal. Like I said, at this point, you know, we can go a little bit more. Sometimes give it a wiggle. Yeah, this one's not wiggling a whole lot, but sometimes when you wiggle, it seats the locks down a little bit more and you can get a little bit more of a turn. And so this micrometer, I believe, goes from 1.4 inches to 2.4 inches. But either way, you know, we know that our range is around 1.8 is the number that we want. And so that's why this micrometer works really well. But then also it accepts these retainers that go on the top here beautifully. So now we need to, now that this is tight, we can go ahead and take a measurement of what this height is, and then we got to do some math, the unfortunate part. So this is by far the most important part of this process. With our setup here tight, we know that this is 1.5, 1.6, 1.7, 1.8, 1.9. You can see we haven't quite reached the 0 mark, but we are beyond the 50 mark. That's what these are in the middle. The small dashes are the 50s. And you can see we can confirm that because we are close to an 80. Further back here, you would find the 50, and it would line up perfectly with this hash right here. So following straight down here, we can basically see that we are at 1.980. That is our current height on this particular valve. And so because we are at 1.980, and we know that our installed height of our valve is going to be 1.8, then we know we need to shim this 0.18 inches. All right, guys, so here is the math. We've got 1.980 with our micrometer. Our installed height we want is 1.8. And what we're trying to determine is how many shims do we need? What do we need to shim in order to achieve the 1.8 installed height? So we're going to take 1.980. We're going to subtract 1.8, right? That's going to be our installed height that we want. And then we're going to subtract, again, our valve seal, which is 0.043 to 0.045. I always go with that lower number of 0.043. And that is going to give us our shim amount that we need. So we need to shim 0.137 inches is what we need to do. And so if we move over here, we've got 2 6s. That's going to get us to 12. And then if we do a 30, that's going to get us to 15. So that's going to be too much. So we're going to jump down to a 15. And that is going to get us really, really close. That's going to be 1.35. So 2 60s and a 15 should do the trick. Let's go ahead and put these in. Before we put our shim stack in, we're going to go ahead and relieve this micrometer. Don't lose your locks. It's a bad day. Go ahead and grab our shim stack, 2 60s and a 15. Go ahead and drop those down. Now make sure that these seat all the way. A lot of times these heads, they have some casting that likes to stick up. So I'll take that first shim and just drop it down in there and just make sure that it is seating properly and doesn't have any wiggle to it like it's getting caught up on any of that casting. Drop the rest, and we're going to take our micrometer again. We need to verify that that is going to be correct. So we've got the locks and the retainer back in there. Go ahead and spin this down. Make sure you can see your numbers. Make sure that that's facing in a direction that you can see them. And now remember, we don't have a valve seal in here. The reason we don't have a valve seal is because this tool won't sit over the valve seal. So the number that we're looking for in this measurement is going to be 1.843 or 45, because our valve seal is going to make up that 43 or 45. So just keep that in mind. I've certainly screwed that up a couple of times already, which is why I had to do practice runs on the other side. So we're going to go ahead and snug this down. Give this a rotate. And we've pretty much got it pretty tight. And what you guys are gonna see is we did make our 1.8 mark right here, but then you're gonna see a 20, 25. So right now we are 1.825. So that is too much. We have too much we're gonna end up with too much installed height. Should mention we wanna wiggle these around a little bit, make sure our valve locks are fully seated. Yeah, see, I just wiggled it a little bit and then gave it another, tried to turn it a little bit more, and we did get to 30. So we're about 15 thousandths off still. So the good news is we have a 15,000 shim. So all we're gonna do is go ahead and pull that 15,000 shim off. This is why you always check it. You don't just shim and go, because it would be awful to be above our 1.8 installed height and be adding a bunch of pressure. Now I've measured these shims from Comp Cams. There are variants in the actual shim stack. So some of these are 16, 17, 18 thousandths, even though they're marketed as a 15. Same thing with the 60s. The 60s, I found some of those to be 65, 70 thousandths. So that's why we're getting this weird number, even though we are using the perfect amount of shims. But we're gonna go ahead and remove this 15 and remeasure. So we've got the 15 removed. I'm gonna spin our micrometer back down. We just barely got it tight, and I can already see that we are at 1.83. So I'm gonna make a little wiggle. We're gonna get this thing snugged up. We're getting really tight now. Give it a little bit more of a wiggle. And then I usually like to grab the top and rotate just the top. Keep wiggling it. See if you can get a little bit more. And that is pretty much it. I don't think we're gonna get any more out of it. Oh, just a scotch. And that is that. Now what I'm seeing on over here is we are at 1.845. So that is right in our tolerance, acceptable tolerance. There we are. So now this tool is tight. We have two 60,000 shims underneath it, and we are sitting at 1.84445. And our valve seal is going to go ahead and make up that difference to give us a perfect 1.80 installed height. Pull the tool off. And now we can install our new valve seal. We do want to give it just a little bit of lubricant. Doesn't need a whole bunch, just a little bit. And we go ahead and install that over top of our seal. I grab a socket and just give that a nice tap to get that seated. Now we can grab our new Beehive valve spring, get him dropped into place. I found with this OTC tool and these valve springs that are installed higher, I had to run a washer underneath it. So I spin these out all the way. Go ahead and get this guy installed. pretty much learned from the factory. These things, they, you know, Ford, Navistar, whatever you want to call, International, they didn't really care about installed height. You know, they were close enough, I think, was kind of their thinking. Give this just a little bit of a snug. And now what's important here is just that when we compress these down, there ain't a whole lot of room. So we want to make sure that that valve stem is coming straight up the middle. Which I am hugging this outside a lot, so I'm just gonna give her a little bit of love here. That's better. All right, let's see if we can put our locks in. We gotta go down a little bit further. Just like that. You can see both of them are in place, and now we can relieve tension and just watch those. Make sure that the retainer captures it, which it did, and the valve started to come up. And boom, that's done. You can kind of tap the top of this. That just helps those locks get set into place. And that one's done. That valve spring is installed, ready to go. 1.8 installed height, 160 pounds of seat pressure. Good to go. Now, some of you guys are going to be concerned with how much we're actually shimming these valve springs. Believe me, I'm a little concerned about it too. But from the research I've done, it is fairly common on these 7.3s, especially if you aren't doing any head work, to need substantial amount of shims. Now, you do have to be concerned because eventually, depending on how far the lifter and valve train actually travel here, you could come bring this valve, where the locks are, down and actually hit the valve seal, or the valve seal could be riding so high that it doesn't properly seal. Now, you shouldn't have to really worry about that. You shouldn't have to worry about that until you start getting above like a 1/4 inch worth of shims. You start getting into the territory of a 1/4 inch or more of shims, and you're gonna want to make sure that that type of contact isn't going to happen. I do also have a small concern for the guys that are running higher RPMs if these springs could kind of move around a little bit. Comp Cams does offer a spring locator. I don't know how they would fit, but you know, just a couple of things to think about. Outside of that, like I said, it's fairly common to have to shim. I mean, we're talking 360,000 shims underneath some of these springs, and so far I don't see there being any issues or problems. We are going to be tearing back into this engine eventually at some point to probably put a bottom end in it. Maybe not even the same block with where this thing is going, but either way, this is the this is a lot better than allowing these valves to float and potentially hit the piston, mess up a push rod, break a rocker arm, drop a valve. That's worst case scenario. So yeah, this is a fairly simple thing to do as long as you know the process and the correct methods of measuring and shimming. So I'm not going to bore you guys with showing you guys the rest of these. Just understand that is as detailed as it gets when it comes to the measuring, the math, and the proper install on these Beehive valve springs. If you're getting them from a reputable company, they will provide you with a installed height. But like I said, you can manipulate that a little bit, kind of depending on how much boost pressure you're planning on running. So nonetheless, this thing is going to be sweet. And the next step in this project is going to be doing head studs. And yes, we're doing ARP head studs one at a time on this engine. So stay tuned. Thanks guys for tuning in. Drop your comments, leave your likes, subscribe if you're new. Catch you guys in the next video. Peace.